And today on the show, we will be discussing Jupiter, the moon, daylight, orientation, and the stars. Stay tuned. Okay, so we were filming the sun setting out here to the southwest, and then we ran over and we took some video of the northeast where Jupiter has rose about a half hour ago, and now we are walking back over to where we filmed the sunset to see that he has now pulled away and only the daylight is visible. Now, if I was to go straight up a couple hundred feet, I would see the sun again. That's not because I'm seeing up over curvature, but because I'm increasing the angular size. I'm increasing my angular size optically. So we are going to wait for the daylight to not necessarily dissipate. We're going to wait for the daylight to follow the sun like an umbrella. The daylight, the electrified air that surrounds the sun is kind of like an umbrella. So the daylight doesn't dissipate as much as the daylight is kind of a cloud of electricity that follows the sun. So the daylight is going to move out of here like the sun did, and it will get dark enough to see Jupiter shortly. And we'll do a quick little moon review. Now, moon is self-luminous. She's not reflecting daylight. Moonlight is cooling, and moon also gives off gamma rays that could not be accounted for with sunlight. And the phases we see are not the Earth's shadow. That is all inconsistent with the science of shadows, light, and reflective surfaces. And as well, there's a darkened area. The darkened area of the moon there's a straight line separating the darkened from the illuminated area twice per lunar cycle. Now, the moon is also not a sphere. One of many ways you can determine this is the rise, zenith, and set features are identical for 3 separate observers simultaneously. And moon is also can be considered like the sister of the sun, as her size, altitude, velocity, and trajectories are all very much like the sun's, just at different times. And now I want to say a few things about orientation to kind of help people understand what I'm saying with my videos here. Okay, so east and west are circles. East and west is how we circumnavigate our world. North and south are straight lines, so if you don't turn, you will end up going north or south. North and south are not mirror images of each other. There's many ways to determine this. Just a few are time zones, wind maps, temperature maps, flora, fauna, climate, elevation, etc. Now, up and down is the same for everyone. When you're in the south, when you're in Australia, you're not upside down. You're not sideways at night. You're not upside down at night. The sky is up and the earth is down. Okay, horizontality. What we observe and what we experience moving around in this world is horizontality. Compasses indicate a magnetic center, and the motion of the sun and the moon clearly demonstrate independent motion over a stationary plane with an axis mundi. 24-hour sun, moon happens only in the north. We'll elaborate on that in a future video. And north and south magnetic poles are asymmetrical in that the south is more like a spring and the north is like a hole. When we look up into the night sky, we aren't gazing into an infinite vacuum. The stars are not that far away. They are within this world with us. The stars, the planets, they're native to this place. It's all one world we're seeing. We're kind of taught to think the stars are inaccessible. And some of them are even dead, but the reality is they're much closer and much more accessible than popular misconceptions would have you believe.